Hey there everyone, welcome back to the 5.4/5.5 factoring and solving polynomial equations. This is part 2. It's pretty much picking up where we left off, and then you're just going to introduce a couple new concepts. But the first couple ones are factoring and solving, just like I did on the last video, but with different patterns here. So this one right here, part A, and actually part B too, but part A and B, these are difference of squares. So difference of squares is you have to have two terms, and both of those terms need to be square rootable, and you need to have a minus sign right there in the middle. Okay, so it's just two terms. Can you take the square root of the first term? Can you take the square root of the second term? And the answer for this one is yes. The square root of 16 is 4, and the square root of x to the fourth is x squared. Just for future reference, anytime you're taking the square root of an exponent, you just cut it in half. So if I said, what's the square root of x to the 50th power? You would answer x to the 25th, because 25 is half of 50. So yeah, I get 4x squared, and the square root of 81 is 9. So what you do is you write it twice, 4x squared and then 9. And then what do you put in the middle is a plus and a minus sign. So we've done difference of squares before, but they were simpler terms like x squared minus 36. That would be x plus 6, x minus 6. Or we saw something like x squared minus 100. That would be x plus 10, x minus 10. You take the square root of each one and make one plus, make the other one minus, okay? So these just look a little different, but it's the same property. So here I have 4x squared plus 9 and then 4x squared minus 9. This 4x squared plus 9 will stay exactly the same. It can't simplify any further. But this 4x squared minus 9 is another difference of squares. All right, so I'm going to put another note here saying that it's another difference of squares. So the reason why I know that is because you can take the square root of 4x squared, you can take the square root of 9, and there's a minus sign right there. The square root of 4x squared, that would be 2x. Divide the exponent by 2. 2 divided by 2 is 1, so 2x. And then the square root of 9 is 3, so make one say 2x plus 3, make the other say 2x minus 3. All right? Make one plus, make one minus. Now this is fully factored, okay? So this is in fully factored form. Once you have it in fully factored form, you need to set each x term equal to 0. So what I'm going to do here is I'm going to do 4x squared plus 9 equals 0, 2x plus 3 equals 0, 2x minus 3 equals 0, okay? So solve each one. Minus 9 to the other side, you get 4x squared equals negative 9. And I don't know if you can tell, but this one's going to be no solution because the only way to solve something with the power of 2 is by square rooting it. So I have x squared equals negative 3 over 2. And so I'd have to square root both sides, and then I'd get an imaginary solution, but I'm not looking for imaginary solutions. So anytime you have to square root a negative number, you can just simply say no solution on that one. Now, there are real solutions here. The 2x plus 3 and the 2x minus 3 will have your real solutions. Just minus 3 to the other side on this one, add 3 to the other side on that one, and then we'll end up dividing by 2. 2x equals negative 3, and 2x equals positive 3. So divide by 2, and we get x equals negative 3 over 2, and x equals positive 3 over 2. And that is our final answer, okay? So it's not like the whole thing was no solution, just that little term with the x squared over here, that just little piece was no solution. These are the two areas, if you were to graph the original, if you were to graph 16x to the fourth minus 81, it would intersect with the x-axis 2 times at negative 3 over 2 or negative 1.5 and positive 3 over 2 or positive 1.5, okay? So with that being said, let's move on to example B. So I'll try and go through this one a little quicker. Example B is another difference of squares because you can take the square root of both terms and there's a minus sign in the middle. So the square root of 625 is 25 and the square root of x to the fourth is x squared. And the square root of 256 is 16. So I'm going to write 25 x squared plus 16 and then 25x squared minus 16. And then I guess equals 0. So the one with the plus sign, there's no sum of two squares pattern, so that one's going to stay the same. The one with the minus sign, that one's going to be difference of squares again. What is the square root of 25? What is the square root of 16? The square root of 25 is 5, and the square root of x squared is just x. And the square root of 16 is 4. So I have a 5x plus 4 and a 5x minus 4. And then I just bring down that 25x squared plus 16. So now this is fully factored. So here, I'll add my equals 0. So it's fully factored. So set each term equal to 0. 25x squared plus 16 equals 0. 5x plus 4 equals 0. 5x minus 4 equals 0. And solve. So the first one is going to end up being no solution because it's going to equal a negative number. So at this point, if you want to just save some time, we'll just say no solution because you can't square root a negative. But this one, I can minus 4 or plus 4 over on these two. And so you can tell that the answer is going to be negative 4 over 5 and positive 4 over 5. But let me finish working it out. So yeah, I just minus 4 over, this one I added 4 over, and then divide by 5. And that's it. These are my two answers. It's not like it's always going to be two answers. Technically speaking, whatever your degree is, this is a degree 4, that tells you how many possible solutions you could have. This could intersect with the x-axis up to 4 times, but it just so happened on these two examples it just intersected twice. All right, so let's move on to the next section of the notes. So here I'm going to determine whether a linear binomial is a factor. What I'm going to do is I'm going to use synthetic division, and then if the remainder is a 0, then it's considered a factor. It's just like dividing regular numbers. If I said, hey, what's 21 divided by 3, you'd say the answer is 7. That's a perfect factor. There's no remainder. But if I said, what's 21 divided by 8, it's 2.625. So if it's 2 point anything, then it has a remainder. And so that means 8's not a factor of 21. So the same kind of logic applies here. So I'm dividing x minus 2 from x squared plus 2x minus 4. So using synthetic division's the quickest way to do that. Remember, synthetic division says whatever you're dividing by, flip the sign. So I said minus 2, so I'm going to write a positive 2. And then you just write the coefficients of your equation, the main part. So this is 1x squared plus 2x minus 4. So 1, 2, negative 4. And so synthetic division goes like this. You bring down the first number, and then you multiply. What's 1 times 2? That's 2. Then add. What's 2 plus 2? That's 4. Now multiply to the outside again. 4 times 2 is 8. Add that to negative 4, and you get positive 4. So the last number is always your remainder, and if that remainder is not a 0, then it's not a factor. And so since it's not a factor, we can just stop right there. Okay, again, that's just because of this property right there. Remainder must be 0 in order to be a factor. So 4, nope, x minus 2 is not a factor. So this next example, very similar. Just if it turns out to be a factor, spoiler alert, it will, then we'll factor it completely. So looking at the problem, when I do my synthetic division, when you set it up, you know you're at the coefficients 1, x to the fourth, 3x to the third. There's no x squared term, so add in a 0x squared, okay? And then minus 1x, and then minus 3. And so that is how you properly set it up. If it skips a term, you need to throw in a 0. What am I dividing it by? X plus 3. So I'm going to put in negative 3 on the outside. All right? So I'm going to do bring down the 1. And so I have 1, and then you multiply it times negative 3. That's going to be negative 3. Let's add those together. That's 0. So now do 0 times negative 3. That's 0. What's 0 plus 0? 0. What is 0 times negative 3? 0 again. What's negative 1 plus 0? Negative 1. What is negative 1 times negative 3? Positive 3. What's negative 3 plus positive 3? 0. So this last term, the remainder, is 0. So that means it is a factor. So I just made that note right there. Now, how do you factor it completely? Well, remember, synthetic division it'll decrease your power by 1 after you divide, because I'm starting with x to the fourth, and then I'm dividing it by an x term. So my answer will start with x to the third, and then it'll go x squared, then plus something x, plus some sort of constant term, plus your remainder. So essentially, after I divide it, I'm left with x to the third minus 1, all right? And so if I were factoring this, then you need to put what you're factoring out on the outside. So we're factoring out x plus 3, okay? So ordinarily, this would be the final answer. But there's more. So I'm going to erase this circle. Why is there more? Well, in the last video, there was the sum and the difference of 2 cubes. And this one is a difference of 2 cubes. So the difference of 2 cubes tells you to, it's the same. It's similar to the difference of squares. Is this cube rootable, or does this have a cube root? Does this have a cube root? So what's the cube root of x to the third? That's x. What's the cube root of 1? That's 1. So you'll plug in. So the formula says a to the third minus b to the third equals a minus b times a squared plus ab plus b squared. So I'm just going to plug in 1 and x for these. So it's going to look like this. So I have x plus 3, that will remain unchanged. And then I have a minus b. So the cube root of x to the third is just x. The cube root of 1 is just 1. So I have x minus 1. Then it says x squared, a squared, so that'll be x squared, plus ab. What's 1 times x? X. What's b squared? B squared will be 1 squared. What's 1 times 1? 1. So this is a long problem, but this is the final answer, okay? And so if you ever wanted to check this, you would graph this, type that in, and then if you type this in, they'll make the same graph. But yeah, that was a long problem. But that's it in its entirety. Let's move on. I got one more thing left to cover in these notes. The last thing to cover is something called the rational root theorem. Basically, it says if you have a polynomial equation with integer coefficients, then every rational solution, where it hits through at the x-axis, has the following form. The factors of the constant term divided by the factors of the leading coefficient term will be a possible solution. Okay, so then you would test each possible solution with using synthetic division. The solutions with the remainder of 0 would be actual solutions. All we're going to do is just list the possible solutions. So we need to figure out what our constant term is, and we need to figure out what our leading coefficient is, and we need to list the factors for such. So this one, I have a 1 for my leading coefficient. How do you know it's leading coefficient? It's the number in front of the highest power. The 20 is my constant term. So that's a sub 0. This one's a sub n. It's not super important that you know that, but it's just, this is how it is in the formula. You see the a sub 0 and the a sub n. So let's list the factors of 20 and let's list the factors of 1. All right, so 1's pretty easy. There's only 1. 1 times 1. But you'll notice everything I wrote is plus or minus, because negative 1 times negative 1 is also positive 1. So I just put plus or minus by all these. So 20 times 1, 10 times 2, 5 times 4. All right, so these are my factors of the constant term. These are my factors of the leading coefficient. Now you just list them. So make a bunch of fractions. So I did my factors of this over the factors of that. So it's just kind of a short list, but I did 20 over 1, 1 over 1, 10 over 1, 2 over 1, 5 over 1, 4 over 1. And technically anything over 1, you don't need to write it as a fraction, but I figure it's easier to teach it if I write it as a fraction, because I'm doing all these factors over 1. So if this had any other factors, I would then repeat this list, take all these and put it over this factor, all right? So that's what it would look like. I'll do one more example like this to wrap it up. So here I have this function. My leading coefficient would be negative 4, all right? And my constant term would actually be a 0, because a constant term can't have any letters by it, all right? So it's not going to be 60 because it's last. The constant term usually goes last, but if it's 0, then it's not going to be written on there. So this is my a sub 0 term. So just to show my work, if I'm going to list my factors of negative 4, they're going to be plus or minus. They're still going to be plus or minus. So I can do 4 and 1. I can do 2 and 2. So those are all my factors of my leading coefficient. And then what are my factors of 0? Well, that's just 0, okay? So the possible solutions would be 0 over 4 plus or minus, 0 over 1, 0 over 2, technically speaking. But since 0 divided by anything is 0, x equals 0 is my only possible solution. So there, I just put that note there. I wrote since, so it should say since 0 divided by anything is 0. So yeah. Other than that, thank you for watching, and goodbye.